This tutorial is going to take a look at an introduction to the Reflex80 relay chatter detector system. The Reflex80 is used mainly for monitoring for chatter events on the normally open and normally closed contacts of electromechanical relays, although it can be used to detect any short-term electrical events that can be translated into a logic level. It's predominantly used for applying chatter tests to military and other relay test specifications, and applied relay testing offer it as a modular system that can provide a number of groups of uncommitted individual inputs. These inputs are normally mapped one-to-one onto individual relay contacts, such that the contact names can be made visible on an operator screen. This page shows you the operator screen before any test data has been loaded. You can see that the grouping here is in groups of 8, and each of these square boxes corresponds to an individual hardware input on the Reflex80. The hardware input is a relay contact, but typically between that relay contact and the Reflex80 itself is some kind of contact conditioning, and applied relay testing provide a range of translation between various relay contact load environments and the actual electronics of the Reflex80. The Reflex80 tests in groups of 8. Each of these 8 inputs can be assigned an individual time threshold, beyond which, if an event occurs, that is considered to be a chatter event. Any events that occur for less than that time are considered to not be chatter events. So these are all set by default to 0.001 milliseconds or 1 microsecond. Before first using the Reflex80, the inputs are configured to tell the Reflex80 how the measurements are going to be performed. By default, each of these inputs expects a chatter event to be an active high signal. So we can click on any of these individual connections and we receive a dialog box that shows us the name of the input and allows us to configure its polarity. Now it's useful to be able to name the input, because clearly if your relay has this particular Reflex80 input connected to the normally open contact 3, then we can make that NO3 and we can save that. So that's giving us a display that shows that input is connected to the normally open 3 contact, and we can do that for any of these inputs. They don't have to be used in order, and we can go through and we can name these whatever we like. So we've configured the Reflex80 to use 3 of its inputs, and you can see the names of those inputs. Now normally this configuration would be saved to a data file, such that an operator who's performing a chatter test simply goes to that data file and opens it. The data file takes care of all of the configuration and mapping of the electrical inputs to the Reflex80 onto the individual relay device contacts. So by loading different data files, you can set up different fixture configurations. The next step after loading this data file, which gives us the individual configuration here, is to do a setup. Now what setup does is setup starts the system monitoring for chatter events. Now a setup is very useful when you first make your electrical connections, or you've placed your bank of relays onto a vibration table. As we all know, it's quite likely that there will be issues with the wiring. Maybe there might be a dodgy connector, and before you start doing test runs and having to go between the Reflex80 and the vibration table while you make modifications, this setup mode is very useful to be able to just glance at the screen and ensure that you get green indicators. Green indicators mean there are no failures. You can see here in this demo mode that individually the inputs are showing a mixture of red and yellow. That's because you can think of each of the inputs as a kind of gas tank filling up. There are numbers inside of those boxes that range from 0, which is implied by the single green, all the way up to 255.